Hi, thanks for having me here. I'm Tomáš, and my speak gonna be about generics. So, sorry, now it works. So, a little bit of theory. So, what are the generics? It's a feature of programming language which allows generic programming. So now, what's generic programming? Uh, To define generic programming, I've used this quote from a book which popularized this term, but the practice was known before. And shortly, it's about separating an algorithm from concrete data type to separate algorithms and the data types, which can be then specified later. So now, what are the options in Go? We can use interfaces. Uh, no need to introduce. So shortly, we can write algorithm around behavior and not about the type itself. And it has one downside that we can't like make it around the operators. Let's say we can't use types, or let's say something which supports plus operator. We have to do wrapping, so that isn't great. Also, we can use empty interface and type assertion. Here we can see an implementation of double linked list, which is kind of generic, but not type safety. So it requires type assertion every time we try to retrieve the value. It should be highlighted. I'm not sure if you can see it, like this line is highlighted, that here we have to do the type assertion. So again, how to achieve the type safety? Do a wrapper. So then we didn't gain much, because then we have to do a wrapper for every type. And also we have a reflection, which is complicated and slow, but it still has its place, like for JSON, because and it makes sense. And last but not least, code generation. Uh, we have a algorithm in one place in a template, but what we have to do is generate the code for every type, and also the functions or methods or type have has this like a suffix, or basically they are, we have multiple of them. And yeah, but so far it's the most performant solution. And of course, show me the true generics. That's why we are here, and why I showed the old ways. And it's because the generics aren't silver bullet, and as every practice, it has its place. And excuse me, now I have a commercial break. I want to introduce you new predicate identifier. It's any. It's new. It's shorter, but it's nothing else that empty interface. And it's used in every good package, and also it's now everywhere in a standard library. And basically that's it. And so the new feature in Go is parametric polymorphism, but let's stay with generics. The syntax is very simple. So yeah, before the regular parameters of function, we can define the type parameters. It's it's here in a square brackets. So here we define function with a t, which with a type t, which can be anything, and then the t is in a we can use as a type of the regular parameter. And later, when the function is called, we don't have to, but we can specify the type before the call of the function. And that's the same thing is for struct or any other type that we define in square brackets the like type, which can be in this example anything. I will get into that later. And here's the thing that t becomes part of that type. So we have to stick them together because there is no s without t. It's always bounded to that type. And some of you may know generics from other languages. And let's say Java, they use angle brackets. But the reason why Go doesn't use angle brackets, there was some discussion about it, is that with angle brackets, the compiler doesn't know what this means. Like it can be like if w is less than x, or it can be function w, and this can be type parameters. So it would confuse the compiler, and it would take longer time to compile if we would use angle brackets. So that's why we end up with the square brackets. So what problem generics solve? Let's take this wrapper of append function. This obviously doesn't work. First reason, we can pass the SL to which is slice of ints to slice of empty interfaces, and again we can like take the return value, the slice of empty interfaces to SL, which is slice of ints. Makes sense. So now with generics, you can see that basically nothing has changed except the definition of the function. The body remains same, and here run it, and here we can call the append, but with the type parameter, but we also don't have to because it is recognized from the regular parameters of the function. So it's nice that we can use it without the square brackets like everywhere. So the whole generics thing is about the type parameters. And what are the type parameters? They are basically just interfaces. Yeah, the significant change, in comparison to using interfaces, is that we can touch the real type. So the variable s in here is of that s type, which is here defined or limited as a stringer, but we like the s will be that time for this call, or time duration in this call. This wasn't possible before without the generics. Also, they are not just interfaces. The interfaces syntax was extended. They like the co-authors added the option, but this option is only for to be used only with generics. You get to it later, but basically you can't use this for your like regular code where you use simple interfaces, and it's called type constraint. What it does is that we can list the types in here, and this union, this typeset limits the that type parameter. So only allow the types which we can use for max functions is int 32 and int 64. With this union, of course, we can use other types, let's say some struct or something, but the only allowed operators or methods are the intersection of that listed type. So in here we can use everything what can be done with integer. But if we, well, it's a bad example, but sure, let's say if we would have their byte slice, then it can be compared or concatenated by plus operator. A tilde token, it like it relieves the limitation to also like types which are like when their underlying type is integer. So basically here we use time.minute, which is constant, and its type is time duration, and type duration is in effect integer 64, but time duration is type on its own. So without the tilde, we couldn't use it. But this tilde like says everything what is at the bottom is integer 64. So basically it works same, but we can use the max function with more types. And of course it can be annoying to list all the types in that interface. We have this package. For now, it's a experimental package, but it does some dirty work for us, and it lists types. For example, well, here the ordered interface is everything what can be ordered. Well, here is the like a documentation for that interface. It's everything where we can use these operators. Also, what you can see here is that we can include other interfaces in the type union. So this integer is also interface which contains signed integer interface and unsigned integer interface, and at the bottom there is the real list of that built-in types. Okay, and another new predicate identifier, it's comparable. It's the only constraint which made it to 1.18 release, and it's dynamic typeset, which includes all types supporting equal operator. So also it includes even your struct, which can be comparable. That means that every field in the structure are comparable. And well, one thing is that comparable doesn't include interfaces, even if interfaces are by the Go specification comparable. So there was some discussion on the GitHub or basically in a mailing list, and the case is not closed yet. So to use comparable, yeah, comparable is very useful when using with generics maps. When using generics with maps, the thing is that the key in a map can't be everything. Let's say the byte slice can be used as a key in a map because it isn't hashable. But also, as I said, the comparable is a bit limited. That should be, or I don't know. But the thing is that like a different set of types, like comparable or what's hashable. And okay, I already mentioned that the type parameters can be inferred, and here's the example that even if we have quite complicated quite complicated definition of that function. It can be handled by the type inferation. Yeah. Sometimes, of course, it isn't possible, but the steps how it's done are defined in a language specification. There are some limits current implementation of generics. Most of them are actually logical, but I think that some like these I will mention are worth to mention. And one thing is that the comparable can be used in a type union. Actually, I don't know why. Let's say it has a reason. And okay, yeah. Also, like what's sad is that the like generics can be based on a struct fields. So let's say we want to make a generic function which takes a struct of which has like a field, let's say name of type string. So what you have to do is again like expose the field through or by some method. Oh yeah, I almost forgot that we can't make a type union with interfaces that contains method. So basically, only interfaces that can be like used in this type union is again interface which is only type union. But this interface, of course, can be like embedded to extend this interface, but can't be used in that type union. Also, logical thing is that like these interfaces, which are also type constrained, can be used as a regular type for your variable. I said already that it can be used only as a type parameter for generic type. And of course, generics doesn't introduce something like dynamic types. So we can't like define that we have this type or interface which is sometimes int, sometimes float, and use it as a dynamic type. This doesn't work. Like the type parameter has to be defined basically during the initialization, so the compiler knows which specific type to use. And as I said, the T or basically all the type parameters becomes part of the generic type. So here we would have to do the T which takes int or float, and here use the T. Okay. This is interesting limit, but also very logical. The basically if you use any can be logical anything. So if the any or basically in fact the T, if the T is integer, makes sense that you can use this variable initialization. So actually, I would abandon this, or I wouldn't use it for generics, because of course you can use it if your type constraint limits only to structs. But let's say later you will add some basic type like a integer, then your code would break, because the integer can be like initialized with the curly brackets. And when to use generics? Well, generics should be used for cases we want them so bad, and that's data structures. and generic operations on built-in data types like slices, maps, and channels. And also, there's one reasonable usage and to implement a generic wrapper, which implements some interface. If that interface's implementation is same for different types. Best is the example, and that's a implementation for sort dot interface, because quite same for all types with some exceptions, but the basics remains the same. For example, the length or the swap that slice or something. That's the how to use generics, and of course we should mention how when to not use generics. Basically, if you don't have to. So if you can use interfaces, use interfaces. And of course, if your implementation differs per type, basically it shouldn't be used, because when you will see this in your code, probably it's a code smell. And yeah, of course, I should mention that the generics comes with performance cost. So every time you use generics, you lose some speed of your program. And yeah, of course, for functional programming, the reason is simple, because the Go doesn't support some optimization which makes function programming fast. Of course, if you will make like a like a chain of functional functions, then you are looping, let's say, like on that slice multiple times. Like I believe it's better to use that or do that in one for cycle. Of course, there's no technical reason why you couldn't do the functional programming, but you again lose some performance. Depends if it's the cost you want to pay. And I mentioned the performance. So said new is that Go 1.18 the compilation is slower, and it doesn't matter if you use generics or not. Good news is that the runtime speed without generics remains the same. Actually, it can be faster because there was some improvements in Go 1.18. And if you use generics, your runtime will be slower. The reason is something I don't understand properly, but it includes something like a virtual meta table. Of course, I will share the presentation, so you can click on this link, and there is a great topic about the great article about this topic, how it's implemented. Basically, and shortly, it's not like in C++, where the code is generated for every type, but the code is generated in some groups, and that's the reason basically, like why it's slower, because it's not and also that's the reason, as I mentioned at the beginning, why the code generators are still the most fastest thing for, of course, some kind of generic programming. And last slide, the coming things in Go 1.19. I'm not sure if it will be there, but there is a good chance that it will be. And the reason for it is that because the Go generics was a huge change on its own, so the Go team decided to not modify standard library yet. The reason is extra time. Also, the backward compatibility, which they now don't have to promise. Basically, this experimental packages can change in the future and break your code. And That's all. Oh, and here is the slice contains font. Most important font for me, actually. And well, that's all.